Hello, chemists. It's Jolly again. Let's finish up talking about those alkenes and alkyne reactions. And so we're going to be doing oxidation, specifically putting an alcohol in its place today. So I'm going to go to the notes and just kind of a variation of what we are going to do. So the first thing we're going to do is acid catalyzed hydration, which is probably of this list, probably the least useful. And then we're going to do oxymercuration, demercuration, and then we're going to do something called hydroboration, oxidation. But the key is we are going to break the pi bond and we're going to put an alcohol in its place. So we're adding an oxygen, hence the term oxidation. All right, so the first one that we're going to talk about is acid catalyzed hydration. And just as the name implies, hydration means to add water, which is exactly what we're going to do. So we're going to do the exact same mechanism. We're going to go through Markovnikov's, and just wanted to point out, this is exactly opposite of dehydration. So when we were doing the alcohols and we were dehydrating them, this is the exact opposite. So if you dehydrate an alcohol, you get an alkene. If you hydrate an alkene, you get an alcohol. And then don't forget, every time you go through a carbocation, look out for rearrangements. All right, so the overall mechanism is just like the other ones in the past. We are going to react it with an acid first. Okay, so this is a very pretty one drawn out for you. You get the ugly version with me drawing. All right, we are going to break that pi bond and we're going to attack the acid. And we're going to break the pi bond, and you put two things in its place. So the carbocation is going to go in the Markovnikov spot or the more stable spot. And then surprise, surprise, if there's not another nucleophile, water is going to come in, squiggle, because you have no control. And there is just a protonated alcohol. And remember, something will come along and deprotonate it. And in this case, it's probably just another water. And you now have an alcohol. All right, so hydration literally is just an addition reaction that uses water as the second nucleophile. Now, can you do the same thing to an alkyne? Yes, you can, but I'll show you hydration for alkynes in a few minutes. All right, the next one, and a very important one, is called oxymercuration and demercuration. Yes, that's a horrible, mouthful of a name, but this one will make Markovnikov alcohols, and it does not go through a carbocation, so there is no rearrangement, okay? There's no carbocation. Now, the mechanism is a little crazy, so I drew it out here for you. I will do, of course, another example, but we're going to go through this one. All right, so we're going to look out for this crazy thing called mercury 2 acetate. Okay, so HgAc2 is what it would look like if we scrunched it up. All right, that is going to put the mercury literally on to the alkene. And here's the key. Here's the key. They both go on at the same time. So if we take this mercury acetate, it is going to break the pi bond. And I know this is a crazy mechanism, so I'm only going to do it in vague terms. You're going to connect there. And so you're going to break the pi bond. And this thing is very large. Okay, very large. So it is going to go on to the anti-Markovnikov spot. And the OH goes into the Markovnikov spot. Okay, so that's the idea behind the oxymercuration. But you have to get rid of the mercury. And so in the second step, you are going to use, this is called sodium borohydride. For right now, it's just memorization. We'll talk about it in the future. So sodium borohydride under basic conditions, this is going to cleave off the Hg and put a hydrogen in its place. Okay, so oxymercuration, demercuration is 2 steps, and it's going to make a Markovnikov alcohol without going through a carbocation and rearrangement. And so here's what it looks like on the reference sheet. Okay. All right. So we're just going to do an example here. I'm going to do my favorite one. Seems like the one I always do. Okay. So the first step is we're going to put the mercury on. And then the solvent is something called THF and water. So the first step is this. Squiggle, OH, and then we're going to put the big old mercury, and then I'll just do a thing right there. Okay, so there's your first step. In your second step, you're going to actually take that off. So sodium borohydride, literally sodium borohydride, if you'll visualize it, as a great big hydride, H minus, that isn't a strong base. I know that sounds crazy. We'll talk about it again in the future. All right, so that borohydride has a little bit of hydroxide with it. It's going to cleave, and ta-da, you have a hydrogen in its place. Change colors here. You have a hydrogen in its place and a Markovnikov alcohol. Okay, this is your go-to reaction to make a Markovnikov alcohol because, I jump back up here. This one can rearrange. And it's great if you don't have to worry about rearrangement, but this one does not rearrange. So it's usually the better option to get a Markovnikov alcohol. All right, that's 2 ways to make a Markovnikov alcohol. How about an anti-Markovnikov alcohol? And this one is called hydroboration. And again, it's 2 steps. So just like that oxymercuration, demercuration, we're going to make kind of a crazy thing called a boron square. It is regioselective. Okay, we are going to make the anti-Markovnikov alcohol. Oh, ho, 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 right here. It is syn addition. Okay, it is syn addition. And we're going to use a reagent called diborane or tetrahydrofuran with BH3. Okay, so either of those 2 will work. And let me see, did I leave myself space here? Of course I didn't. So we're going to go to the whiteboard for this one. All right. Hydroboration. Start with my favorite alkene. All right, the first set of conditions is either going to be THF and BH3, or it can be that diborane. So either one of those conditions work. Okay, now the key here is this is going to come, and I know this is a really horrible, horrible picture, but we're going to picture all right, it has an attachment that's big. So the diborane has a really big part, or if you attach the BH3 to the THF, so there's a big portion. So when it sees this alkene, if you will notice, it has to come and align so that the steric hindrance isn't too crazy. So the boron is actually going to come and attach, and this is what I meant by a diboron square. So the pi bond is going to break, and it is going to make the boron square. Okay, so if you'll picture, change colors. There's a square right there. Okay, so there's the first attachment. And the reason this works is this will go to the less sterically hindered side. Well, now we have a great big old square stuck. But if you'll notice, what went into the Markovnikov location? A hydrogen. So I'm not defying stability and I'm not defying sterics. I'm making it work in my favor. All right, so I have this wonderful little square now. And then my second condition is going to take it off. So we're going to use some hydrogen peroxide. Okay. And I'm just double checking the notes here. Hydrogen peroxide, that's basic. All right, this is going to come and it's going to cleave the square and put an OH in its place. So I use sterics to my, favor this time. And in fact, I did it both ways. So the mercury was sterically hindered, and I used it to make the Markovnikov alcohol because the OH went on first. Well, I used sterics to my advantage this time because the hydrogen went on first. But this is a way to make an anti-Markovnikov alcohol. So that is hydroboration. That's hydroboration. All right, now let's look at those alkynes. All right. We're going to talk about these in a different video. All right, alkynes. Okay, we've talked about the hydrohalogenation. We've talked about halogenation. So what we need is right here. The addition of water. Can you actually hydrate an alkyne? Well, sure you can. Okay, it just has pi bonds. So my favorite little alkyne right there. So we're going to add some water to it. And in this case, it's going to be a little bit different because I need just a little boost, okay? And we're going to add, again, no surprise. Mercury works really well in this case, okay? So this is my little boost if you really want the hydration to be effective. All right, we are going to attack. Okay, now if this is under acidic conditions, that would be a proton, okay? And you know what? I better write it that way. Oops. So the three conditions are acid, water, and then this mercury 2 sulfate. But the pi bond is, of course, going to go after the acid, and it is going to break. And you're going to make the Markovnikov carbocation. Hey, but guess what's also available? So your second step, the water comes in, and we have got okay, now I have to change colors. Ooh, let's go blue. Oh, look, look, look. That is an sp2 hybridized carbon. You're not allowed to put OHs on an sp2 hybridized carbon because guess what? This is a carbonyl in a disguise. So this will now result in keto-enol tautomerization. And I'm going to jump to the whiteboard. Oh, no, I'm not. I'll just jump down here and we'll do hydroboration on the whiteboard. So right now, what I've got is this crazy alcohol on an sp2 hybridized, okay? And then, of course, something will come along and deprotonate that. So I have this. All right, well, what is going to happen? Hey, I'll take that hydrogen. I'll form a double bond. And guess what I have? I have a carbonyl in disguise. This is a ketone. So when you do hydration of alkynes, you don't end up with two alcohols on your molecule. You literally end up with a carbonyl because of ketoenol tautomerization. And you're never going to end up with an aldehyde because this spot right here, sorry, is not a stable carbocation, so you'll never get that. You will always end up with a ketone. All right, so there is hydration of the alcohols. We just need to do hydroboration, and there is no oxymercuration, demercuration of alkynes. Okay, now let's do hydroboration. So again, my favorite alkyne to use as an example, and we're going to use the same conditions. 1 BH3 THF or the diborane. This is just the one I usually use. Okay, so the first step is again going to make that diboron square. I said diborane, just boron square. Sorry, my pen is really particular today. All right, where am I going to put things? Again, the hydrogen and the boron are going to use sterics to their favor. So this will go to the H side. This will go to the Markovnikov side. And we are going to end up with we're going to end up with that. And again, what is going to happen? We're going to do our second step, and it's the hydrogen peroxide. Basic conditions, and we're going to break it. Oh, guess what? sp2 hybridized carbon. So again, this is ketoenol tautomerization. Only the unique thing is, do you see? This is on the end. So this one will actually tautomerize into the aldehyde. Come on, color. Oh, a way to get an aldehyde. All right, so again, I'm using sterics in my favor. I'm not like violating any steric hindrance or stability rules. I'm just using it in my favor. All right, let me go to your reference sheets. And where are you, reference sheets? Oh, I was already there. Okay, let me go up to alkenes first. All right, we did hydration, we did hydroboration, and we did oxymercuration, demercuration. Those will all make alcohols. And the reason you have 3 of them is because 2 of them are for Markovnikov alcohols, and 1 of them is for anti. All right, for alkynes, We just did hydration and hydroboration, and I made a little note for you here. Remember, it makes an enol. An enol is when you have an OH on an alkene. So there's the ene portion, there's the ol portion. So you go through an enol, which means an alcohol on an sp2 hybridized carbon. And so it doesn't matter whether it's terminal or internal, you are going to end up with a ketone. But with hydroboration, again, we had that enol, but if you have internal, it will end up as a ketone. But the example I gave you, it was a terminal, okay, so that alkyne was on the end, and so we ended up with an aldehyde. So there's two ways to make ketones, but there's also one way to make the aldehyde. All right, and that finishes this little lecture on putting alcohols on the pi bonds, and in the end, on the alkynes, it turns into a carbonyl. All right, until next time, Jolly out.